Good evening, Algebra learners. So we are going to continue in section 3-3. And remember, in chapter 3, we're talking all about inequalities. And today we're going to start doing some one-step inequalities where we're going to use multiplication and division to solve. So something I'd like for you to remember is when you multiply or divide by a negative number in an inequality, you flip the direction of the inequality. That is very, very important. Only when multiplying and dividing by a negative number do you flip the direction of the inequality. You're going to see that in action here in the next couple examples. So here we have example 1, and it says, what are the solutions of x over 3 is less than negative 2? I'm going to rewrite that over here just so I can write on it a little bit easier. And remember, we've talked about how we get rid of fraction bars. A fraction bar means division. So to do the opposite of division, I'm going to multiply. So I'm going to multiply by 3 on the left and right sides. They cancel on the left. Because I multiplied by a positive number, I'm going to leave the direction of the inequality. So it's going to be x is less than negative 6. And I'm done with that. Now I need to graph it. So we're just going to fill in our number line with the appropriate numbers. And then it says x is less than negative 6. So I'm going to go to negative 6 and put a circle on it. Now this circle needs to remain open because it's strictly less than. Then I need all the numbers that are going to be smaller or of smaller value than negative 6, which is going to go to the left. So I'm going to shade that number line to the left some, drawing my arrow, and I'm good to go for that one. For the next one, it says, what are the solutions of c over 8 is greater than 1/4? So once again, I'm going to write it over here to the edge just so I can work on it a little bit or write on it a little bit easier. And then I want to get rid of the fraction on the side that the variable is on. So that's the left side. It's c divided by 8. Remember, fraction bar means division. So to get rid of divided by 8, I'm going to multiply by 8 on the left and right side. So these cancel, and I have c is greater than 1/4 times 8 is going to get me 2. So now I have c is greater than 2, and I'm going to start filling in my number line again. I'm going to go to the 2, put a circle on it, and we're looking for the numbers that are going to be of higher value than 2, because c is greater than 2. Or remember that trick, when the variable's on the left-hand side, we can shade in the direction that the inequality is pointing. So it is pointing to the right. So I'm going to shade everything on the right side of this number line. Alrighty. For our next example, it says, what are the solutions of negative 3/4 w, and then we're missing an inequality sign. Let me write that in. Negative 3/4 w is less than or equal to 3. Alrighty. This time I have a fraction multiplied by the variable. In order to get rid of that fraction, I am going to multiply by the reciprocal. Remember, the reciprocal is just that number flipped upside down. So I'm going to multiply by 4/3 on the left side, and I'm going to multiply by 4/-3 on the right side as well. We're always doing the same thing to the left and right sides of the equation. On the left, those are going to totally cancel, and I have w is greater than or equal to. So notice how the sign was pointed to the left and now it's pointed to the right. Because I multiplied by a negative number, that's why I'm flipping this sign around. Then I have 12 over negative 3. Let's reduce that, and I'm going to have W is greater than or equal to negative 4. Now it's time to graph. Okay, so I'm going to go to the negative 4, put a circle on it, and notice because we have that or equal to symbol, I'm going to fill in that circle. I'm going to color it in. Then my arrow is pointed to the right, so I'm going to shade everything to the right. Please take note, you can only use that shortcut if the variable is on the left-hand side. You can only use the shortcut of knowing which way to shade based off of the direction of your inequality sign if your variable is on the left side of the equation. Okay, let's flip that paper over and do some more examples just so we can really get it in our bones. So example 3 says, what are the solutions of negative n over 3 is less than negative 1? I want to get rid of that negative 3. Remember, this means n divided by negative 3. To get rid of the division, I'm going to multiply by negative 3 on the left and multiply by negative 3 on the right. They cancel on the left, and I have n is greater than positive 3. It's greater than because I multiplied by a negative number. So I took this sign and I flipped it backwards. It's positive 3 because a negative times a negative gets me a positive. So now I have my solution, and I'm going to make a number line. So 3, 4, 5, 6. Okay, I'm going to the 3 because that's what my solution is. I'm going to put a circle on it. It needs to remain open because there's no or equal to symbol, and it's going to the right. All right, now we're getting into the dreaded word problems, but that's all right. I'm going to show you how I kind of break them down, and if that helps you, then you can use this strategy when you're solving word problems on your own. So it says, you walk dogs in your neighborhood after school. You earn $4 per dog. How many dogs do you need to walk to earn at least $75? Alrighty, so what I want you to notice is what are the two things that we're comparing. We're trying to figure out how many dogs we need to walk in order to earn money or a goal. So I'm going to compare how many dog walks I've had compared to my goal. These are the two things that I'm comparing. Next, I want to consider, do I want the amount of money or the amount of money that I earn, based off of dog walks, to be more or less than my goal? Do I want it to exceed my goal? Yes, I do. I want the amount of dogs that I walk to be more in order for me to earn more money. But if I make exactly the right amount of money, then I'll be happy with that too. So this is just the broad general idea of what I'm doing. So I'm comparing how many dog walks I've had based off of the goal amount of cash, and I'll put a little dollar sign right there, the goal amount of cash that I want to earn. So now let's reread this and see what we can figure out. You walk dogs in your neighborhood after school. You earn $4 per dog. Okay, that $4 per dog is going to go with the dog walks because we're walking dogs and getting $4 per each. So I'm going to say $4 per dog walk. How many dogs do you need to walk in order to earn at least $75? That $75 is our goal. So I'm going to put 75 on that side and then my inequality symbol. Now it's just time for me to solve. I'm going to divide by 4 on either side, and I'm going to get D is greater than or equal to 18.75. Now here's what I want you to think about. Are you able to give 3/4 of a dog walk? Not really. So it's impossible to give 0.75 dog walks. So now what we're going to have to consider is, should I round up or should I round down? Well, we want to round up because we want to make sure that the amount of dog walks and the amount of money that we earn is bigger or more or greater than our goal. So I'm going to say D needs to be greater than or equal to 19. And that's going to be my final answer. For our next problem, it says a student club plans to buy food for a soup kitchen. A case of vegetables costs $10.68. The club can spend at most $50 for this project. What are the possible number of cases the club can buy? So once again, we're comparing two different things. We're comparing a budget because the club can spend at most $50. So we have a budget, and we also have our money spent. We're comparing how much money we spend to how much money we are limited on spending. Next, we want to ask ourselves, do we want what we spend to be more or less than the budget? We want what we spend to be less than the budget. If we spend more than what we have, then we won't be able to afford what we're trying to purchase. But we are able to spend exactly $50. So I'm going to put an or equal to symbol in there again. Now let's reread our problem, now that we've kind of broken it down with its fundamental parts, and let's start inputting some of our numbers. So a student club plans to buy food for a soup kitchen. A case of vegetables costs $10.68. So this is what we're spending. We're spending money on vegetables, and it's $10.68 per case. So I'm going to say $10.68 per case needs to be less than or equal to, and then the club can spend at most $50. So this $50 is my budget. Now I have my equation completely set up. Let's divide and solve for this. So I have divided by 10.68, divide by 10.68. C is less than or equal to, when I get that, I have 4.7. Alrighty, this is another situation where we have to stop and think about whether or not our answer makes sense. Just like you can't take a dog on only 3/4 of a walk, we also cannot buy 0.7 of a case of something. Otherwise, it would be a totally different product. So what we need to ask ourselves is, should I round this 4.7 up or should I round it down? This time, even though it's a 0.7 and you'd think, hey, round up, we actually need to round down. We're going to round down because we can spend less than the budget, but not more. So if I were to round up, then I would no longer be satisfying C needs to be less than 4.7. 5 is not less than 4.7. 5 is more than that. So instead I need to go to my next number, which is going to be 4. So C is going to be less than or equal to 4. For our very final problem, it says, what are the solutions of negative 9y is less than or equal to 63? I'm going to write it out over here to the side. And we know that we need to divide by negative 9 because this is negative 9 times y, and I do opposite operations to isolate the variable. Now I have y is greater than or equal to negative 4. I flipped the sign because I divided by a negative number. Let's fill in our number line. Oh, I'm going the wrong way. And I'm going to go to the negative 4, put a circle on it. And because I have this or equal to symbol, I'm going to fill it in. Then, because my variable is on the left-hand side, I'm able to look at what direction this is pointing, which it's pointing to the right. So then I know that I can shade in anything on the right side of that dot. All right, that is everything for this section of notes. If you have questions, please bring them to me in class tomorrow, and have a good night. Bye.